react the Grignard with? What did we react the Grignard with?
CO2.
That's right. CO2 followed by what?
Water.
That's right. All right. So you guys remind me again. What was the other way of synthesizing the carboxylic acid? Without looking at your notes. All right. Without looking at your notes.
Making a nitrile.
That's right. So how did we make a nitrile?
Through an SN2 reaction.
That's right. So if we want to do an SN2 reaction, what would we start off with?
We need a good lead.
That's right. You can start off with an alkyl halide and then do an SN2 on the alkyl halide. But because we started off with an alcohol, it was a bad leaving group. So we had to convert it to a good leaving group. Right? And then react it with the CN minus to form the nitrile. And then we do what? Right. Using what?
H3O plus and P.
Okay. Cool.
You like say it fast, remember H. Yeah.
Actually, great.
The practice problems make everything real.
All right, cool. So this is the first question, all right?
Mm-hmm.
So we have this alkyl halide, and I have different steps here.
Mm-hmm.
So you guys gonna walk me through this? What's gonna happen?
Well, wouldn't like the first step, the MG like go in between?
That's right. So we'll go here, and then we would generate.
Can you draw the CO2 so it's like so BR is your nucleophile, so it'll go into the carbon, right?
BR?
Or I don't know what's a nucleophile actually.
It's okay. So we're going through the practice problems.
Oh, the R group is
Perfect. Excellent.
Okay.
Excellent. So what's going to be my nucleophile? Do you guys mind drawing it out on a sheet of paper? And if both of you guys can do it, it'll be good. You're kind of like watching. You're like watching from the side.
I figured it out.
You figured it out. I figured it out.
Yeah, and I didn't
So
want
just draw it so we can, be sure you guys
I
both
lost
here.
the pen again.
I got an extra pen.
I got it.
Okay, cool. Terrific. Let's start to point out a couple of things here, right? Right, this is my nucleophile, right? Notice there's a carbon here, right?
Mm-hmm.
So my nucleophile is going to be this.
Okay.
And this nucleophile is going to react, because there's going to be a polarity here. This is going to be partially positive, partially negative, partially negative. So this is my nucleophile. It's going to attach to the electrophile, right? This electron is going to come over here, okay?
Oh, so it was this carbon then that comes.
Yeah, but you just gotta know that carbon kind of adds on to that one.
So we call this number 1 here.
Mm-hmm.
This would be number 2. Right, so we can just draw this out like this. This would be 1, 2, so we know our carbonyl should be on the second one. And we have that. It doesn't matter if you draw it up or down, right? So you guys, in case you're worried.
No.
Right. Okay. Excellent. All right. And then we just follow it with the acid, right? And we would have this here. And actually, we gotta put one more carbon on here. Cool.
Yep.
All right. What about the one below this? What would happen?
Just because that's
Yeah, the reason why I'm doing it this way is because I anticipate some, sometimes on the exams they like to switch up things. They do a little bit of switch up and that can get you.
Is that
it does.
But do you know what this does?
that should?
Together?
Yeah,
Well, the number one is your alkyl halide, right?
that's right.
So it creates your linear when you throw it together. I don't know.
That's right. That's exactly what it does.
Okay.
That's exactly what it does. So what would the granular look like then?
It would be just throw the MG for the eyes, so like MGI, I guess.
Okay, so you mean
CH3, CH2, MgI.
Yeah.
like that, right?
Right.
Yeah. So then what would happen with this then?
Um,
What would happen with this?
your R group is going to act as the nucleophile to attack your electrophilic center.
That's right.
C. It's,
So it's right here, right? So then you're like,
If you're confused, just number the carbons. If you get confused, just number the carbons.
so
Yes.
left with the.
Yep.
I hate when they write it like that because what ends up happening, I end up getting mixed up as
I
to
know,
what
I
it
understand.
means because they switch it up.
I understand.
Because I mean, the way that I look at that is that one, the nucleophile is going to automatically attack,
Yeah.
but that's not really how that is. That's wrong.
They do stuff. They mix it up and they might change. Or they might ask you to figure out what you would begin with to form a certain product.
It's just wrong. I mean, like,
It's just a different way. They're testing your the way you comprehend it.
I don't know. Do whoever destructs.
oh, Taylor.
Alright. Okay, so how about the next one? Oh, actually, we don't have a. This will be a carboxylate.
Yeah.
We don't have an acid work up here. Alright. So just write the product you would form for the next one. It's okay. It's okay. So this one, what reaction was this? This is hydrolysis, right? And what is this? What functional group is this? Or what carboxylic acid derivative is this? That's right, nitrile. So if you see acid with heat and you see a carboxylic acid derivative, hydrolysis. If you do hydrolysis, what are you forming? That's right. So the mechanism for this one is a little bit harder than the rest of them. because this nitrile guy is kind of weird. Well, he is weird. So this carbon here is this carbon here.
Okay.
And so all of them can undergo hydrolysis. The amides, the esters, acid halides, the anhydrides, all of them. They can all be hydrolyzed back into the carboxylic acid. Alright, what about this? What would happen here?